Let's look at an interesting idea that pops up from time to time on some standardized tests. Okay. And this is just a parlor trick for what to do with large powers of I. So we know that I is the square root of -1. And we know that I squared, therefore, is the square root of -1 squared, which we've said is -1. So what does that make I cubed? Okay. I cubed is I squared times I. If we decompose this, right? Let's think about that for a second. When you multiply powers that have the same base, you add their exponents. So I squared times I is really I squared times I to the first. And I squared is -1 times I, which is equal to -I. So in other words, I to the third power is equal to -I. Okay. So what does that make I to the fourth? I to the fourth could be written in one way. It could be written as I squared times I squared. If you're thinking like, well, why didn't you write that as I cubed times I to the first like you did here? Well, here's why. Because what's I squared? I squared is -1. What's this I squared? Also -1. What's -1 times -1? +1. So I to the fourth is equivalent to 1. Let's keep going. What's I to the fifth? How am I going to write I to the fifth? Now, I've got any number of ways I could choose to decompose that, okay? But what makes the most sense is this is I to the fourth times I to the first. Why am I using I to the fourth? Because I to the fourth is equal to 1. So I to the fifth is really 1 times I, which is I. So I to the fifth is the same as I to the first, okay? Let's get one more and see if you're catching on. What's I to the sixth? I to the sixth is I to the fourth times I squared. And I to the fourth is 1 times I squared, which is -1. So we get an overall value of -1. So even though the powers of I keep increasing, my answer is always going to be one of these answers. It's either going to be I, -1, -I, or +1. Okay. Let's jump forward a little bit. Let's keep it manageable though. Let's go I to the 14th power. Okay. I to the 14th power. Remember that when we want to decompose this, it's the sum of these numbers that gets me this, right? These powers, these exponents. So I to the fourth is I to, or excuse me, I to the 14th is I to the fourth times I to the fourth times I to the fourth, that's 4 plus 4 plus 4, that's 12, times I squared, which is 1 times 1 times 1 times I squared, which is -1, which is equal to -1 as well. Okay, let's keep going. What's I to the 23rd power? Okay, I to the 23rd power, how many of these am I going to have, right? We're looking to unpack all of the I to the fourths. We want to put I to the fourth as many times as we can without getting past the 23. So in other words, it's a multiple of, and this is going to sound odd, but it's a multiple of fourths, right? I to the fourth times I to the fourth times I to the fourth times I to the fourth. That's 4, 8, 12, 16, 20. And then there's 3 i's left over at the end. What is I to the third power? Look back up here. I to the third power is equal to -I. So you're going to get a problem if you take the SAT or if you take the ACT. I can't guarantee you're going to get one, but it may come up. They're going to say, "What's I to the 57th power?" And you're only going to have 4 choices, right? It's a multiple choice test. It's one of those 4 values. How do we know which one it is? What is the closest multiple of 4 to 57? Okay, I'll give you a second to figure that out. Right? What are the multiples of 4? 4, 8, 12, 16, yada, 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 yada. 60 is a multiple of 4, but that's not quite to 60. So the multiple of 4 that's less than 60 is 56. So in other words, I to the 57th power, I could do all of these, right? I could write them all out. I would have 14 of these because 14 times 4 is 56, right? And eventually I would write 14 of these, and that would get me all the way to I to the 56th power. Then I'd have to multiply by one more I to the first in order to get to that 57th power. And I to the first is equal to I, right? So really what we're looking for is what's the closest multiple of 4 that I get to with this number without going past it, and then count up another power of I to get to that. One more, just for the sake of let's do 121. Okay. So you can go off to the side or even on a calculator and say, okay, well, 121 is divisible. It's not equally divisible by 4, right? But I can figure out what the closest multiple is. How about some long division here? Okay. 30. 4 times 30 is 120. Here's our remainder. So in other words, this is I to the 30th power, okay? I'm sorry, I to the 120th power, my fault. I to the 120th power, and then we have one more, because this is packed full of I to the fourths, I to the fourth, I to the fourth, I to the fourth, I to the fourth, which is all 1. So we're multiplying times 1 times 1 times 1 times 1, and we end up with just this. Okay, neat little trick. Again, I've seen it on an SAT, I've seen it on an ACT. Whatever the closest multiple of 4 is to this power without going past it, and then tack on however many i's. It'll be 1, 2, or 3 that you need to get to exactly that number.